Okay, so today we're going to look at the unit circle and trig ratios. So to start off with, I've drawn here a unit circle with an angle and a arm here that goes to a point P that has the coordinate points of cosine and sine of this angle here, of the acute angle. So a couple of things just to make sure everybody remembers. We have quadrant numbers, quadrant number 1, quadrant number 2, 3, and 4. And we can talk about sine, cosine, and tangent based on this little guy here. Now the radius is technically a 1 here, because our radius in a unit circle is 1. If it was not a radius of 1, then we would have a number for obviously this value here. We then have a x value and then a corresponding y value. So when we talk about sine, we know sine is opposite over hypotenuse. So in this case here, sine is going to be y over 1. Which also, if we wanted to write it even more broad, we can say it's y over r. So that's why when we look at the coordinate point for the point, sine of theta is ultimately on a unit circle equal to the y coordinate. When we look at cosine, cosine is adjacent over hypotenuse, so again, adjacent here is your x, and we're going to be over 1 for a radius of 1. We can generalize this to be x over r, and again, because x over 1 reduces just to the x coordinate, cosine of theta is equal to the x coordinate. Tangent is going to relate to the slope. Slope is y over, or rise over run, so y over x. Rise over run, and it actually relates to the slope of this line. So if we actually look at a couple of things for the quadrant, because x and y and the radius is positive, all components, sine, cosine, and tangent, are all positive. If we were to look at an angle in the second quadrant, over here, now we have an x value here that is going to be negative. So that will then affect our cosine and our tangent because they'll both become negative. So as a result, sine is going to be positive in this quadrant. When we go into the third quadrant, same idea, our x is going to be negative and our y is going to be negative. That means our sine and our cosine are both going to be negative, yet our tangent, a negative divided by a negative, becomes a positive. So tangent is going to be positive here. When we look at the final quadrant, we will see that, again, based on the sine, in this case here, our y value is going to be negative, but our x is positive. The one with our y is going to be, sine will be negative, and tan will be negative, but cosine will be positive. So there is a little acronym, whichever ones you prefer to use. All students take calculus, CAST, there's other acronyms I'm sure as well, but it goes all positive, sine positive, tan positive, cos positive. So using this information that we just talked about on the unit circle, there are some coordinate points that are nice and easy based on standard angles. Here, my angle is 0 radians or 0 degrees. If we're talking a full rotation around, then theta could be 2 pi radian or 360 degrees. This will then tell me that the cosine of 0 or the sine of 0 equals 1 or 0. Same here. My angle at this point will be pi over 2 or 90 degrees. We're just doing a straight first quadrant rotation. We would then have, again, cosine of pi over 2 is then going to be 0, and sine of pi over 2 is going to be 1. Same idea here. Our angle would be pi or 180 degrees. Cosine of pi is going to be -1. Sine of pi is going to be 0. when I look here and I do a full rotation from initial arm to terminal arm, we're looking at theta is going to be 3 pi over 2, or 270 degrees, and the cosine of that will be 0, and the sine of it will be -1. Now there is one thing just to notice, and we'll use it a little bit in this unit, but the equation for a circle is x squared plus y squared equals radius squared, and in this case our radius is 1. So we may use this when solving for a side if we were looking at, or a coordinate point. We will see a couple examples using this. So if we were now to look at an example where we've got four angles that are related to each other because they have a similar reference angle. Now what I mean by reference angle is that we can work in a quadrant 1 using an acute triangle quite nicely, but now we're going around, so we're not actually making a triangle here, we're making a giant arc, but it does relate to a very similar triangle, which has a reference angle here that is equivalent to the one that is in quadrant 1. So in quadrant 1, we have a nice acute little triangle. We can then use our special triangle information. We have pi over 6 for our reference, and the other angle up here is pi over 3. So this triangle here, this ratio, or these ratios that go based on each of the sides, can be utilized in the same one here. The reason why is this angle here, if I take pi minus 5 pi over 6, now I've got 6 over 6 pi, it's going to leave me 1 pi over 6. So it has a similar reference angle. Same idea down here in quadrant 3. We have a larger angle, 7 pi over 6, but again, we can create a similar reference angle here. In this case, I would have pi plus pi over 6, and again, 6 over 6, that'll give me my 7 pi over 6. So I can also do 7 pi over 6 minus pi, and that would get me my pi over 6 reference angle. If I look at this one down here, again, similar reference angle. The reference angle will be pi over 6 because I can go 2 pi minus my 11 pi over 6, 12 over 6 is equal to pi over 6. They all have the same reference angle. So this is your reference angle for each one of them. They all use the exact same similar special triangle. As a result, I can look at finding my sine of my angle, cos of my angle, and tangent of my angle using the ratios that we have for a special triangle. Now I briefly talked also about that the sine, for which one will be positive, is based on the acronym either CAST, if you start with C-A-S-T, or all students take calculus. Whatever you remember, there are other ones out there, whichever one you wish to remember. So sine for pi over 6, opposite our hypotenuse, is the ratio is going to be 1/2. Cosine, root 3 over 2, and tangent, 1 over root 3. They're all positive ratios because we are in quadrant 1. In quadrant 2, we can use the same information. Sine of our new angle, 5 pi over 6, cos of 5 pi over 6, and tan of 5 pi over 6. They will have the same ratios. The difference is that sine is positive, the rest are negative. So I would have 1 over root 3, I would have root 3 over 2, and I would also have 1/2, where only the sine is positive. When I look down here, same idea. The ratios are all going to be exactly the same. The main difference, again, is the sign of the ratios. So in this case, tangent will be the one that is positive, cos will be negative, sine will be negative. So negative 1/2, negative root 3 over 2, and negative 1 over root 3. Same thing goes here for 11 pi over 6. Again, the difference is only cosine is positive. So again, sine of your theta of 11 pi over 6 is going to be negative 1/2. Cos is going to be the positive 1 of root 3 over 2. And tan of the angle is going to be negative 1 over root 3. You can definitely rationalize the tangent one, so it would be root 3 over 3. So that is your choice as well, but you don't have to in this case. I'm just showing you a quick example. So looking at that, we can now see that every scenario has, sine will have a positive and a positive, cosine will have a positive, and tangent will have a positive down here as well. So there's always two occurrences within 360 degrees or 2 radian where they have the same sign. So it is important to remember that when you are solving the other way around and trying to figure out what angle it is, there are technically 2 angles that have the same ratio. So you need to consider which quadrants they're going to be in. Another example that you might see is one where they give you a coordinate point. They don't necessarily tell you if it's a unit circle or not, but in this case, given the coordinates, you can actually figure out what the actual sides are if you wish. So here's what we're going to do. We're going to figure out what sine, cosine, and tangent are. Sorry, I think this example I did want to make them. Yeah, actually this one was the one that I wanted to have a unit circle, so I just haven't written down my 1. There we go. So then as a result, we know here and here, because it is a unit circle, this one here is going to be our cosine of our angle, and this one here is going to be our sine of our angle. So sine is going to be negative 4 over 5, and cosine is going to be negative 3 over 5. So then the question is, how do you figure out what tangent is? Well, in this case here, we know that it's negative 3 over 5 over 1, because that's our radius, and this one's negative 4 over 5 over 1. We then can consider that all students take calculus. We know then this quadrant is going to have to be positive for first of all, but we also know that this is your x and your y coordinates, so my rise over my run. So I will have negative 4 over 5 divided by negative 3 over 5. As a result, when working with fractions, we can then basically do this, and the positives, it will become a positive. Negative times a negative is a positive. The 5s will cross out, and we will get 4 over 3. So now we now want to look at these 3 ratios here. Cosecant is the same as 1 over sine theta. Secant is the same thing as 1 over cos. And cotangent is going to be 1 over tangent. Which means if I go 1 over a fraction, it's going to have the reciprocal, so I will then have negative 5 over 4, negative 5 over 3, and positive 3 over 4. So I can find my ratios quite simply.